In this video, you will learn how to write the equation of a hyperbola given the critical information of the foci and the vertices. If we look at example 5, we are asked to write the equation of a hyperbola with foci at -4, 0, 4, 0, and vertices at -3, 0, and 3, 0. Again, like before with ellipses and parabolas, I would recommend you draw a picture. So let's plot those points. So the foci are the ones on the outside, and the vertices are on the inside. Now, the first thing that I need to write my equation is I need to know the center. This would be the midpoint of either the foci or the same midpoint for the vertices. You can also look at them and tell what at least the y value of the center would be. You see how they're the same y value for the foci and the same y value for the vertices? That means the y value of my center at least needs to be 0. And if I found the midpoint for either of these, I would see that my center is going to be at 0, 0. Now, you can also visually look at it, count in one vertice, 2, 3, go to the other vertice, count in 1, 2, 3. The place where they match up will also be your center. Now, once you know your center, the vertices tell you how far away from the center you get, which gives you the value of A. Here, we are 3 units from our center, meaning that A is a value of 3, and therefore A squared will be 9. The foci tell me how far from my center I am, giving me the value of C. Here, we are 4 units from our center. I can use this information in our equation, C equals the square root of A squared plus B squared, to find out what B squared is, which is what I actually need for my equation. So plugging in what I know, C being a value of 4, A squared being a value of 9, squaring each side to get rid of the radical, and then subtracting the 9 from each side, I see that B squared is a value of 7. At this point again, I like to set up the basic structure for a hyperbola. We know it's equal to 1, and we know it's subtraction. Based on how I plotted my vertices and foci, I can see that this must be horizontal. If this is going to be horizontal, x squared term must be the positive and therefore first. Therefore, y squared is second. At the same time, a squared is always the first denominator, and then b squared is always the second denominator. I can now look at example 6 and do pretty much the same thing. I'm going to start again with the diagram. My foci are at 0, 2, and 0, -2. My vertices are at 0, 1, and 0, -1. Finding the midpoint between either pair gives me again a center of 0, 0. The distance from the center that my vertices are is a distance of 1. Meaning that both A and A squared is a length of 1. My foci are 2 units from the center. Again, if I plug into my formula what I know, square each side to get rid of the radical, I can see that b squared is a value of 3. When I again set up my basic hyperbola, because this one is vertical, I want to make y squared the positive term and therefore first, x squared being second. The fact that it's vertical, though, does not mean that I move a squared somewhere else. I still want a squared to be the first denominator and b squared to be the second, even though that a squared is a smaller value. At this point, please pause the video and complete examples 7 and 8. Please now check your answers for examples 7 and 8. When you are finished, please talk with your partner about the similarities and differences that you notice between a vertical and a horizontal hyperbola.